Centroid. These three things we'll look at. So actually we already have a video before about what you can do when you have 3 points. In fact, we started with saying, if you have 3 points, can you draw a circle through it? And the way we did that was, we basically thought of it like a triangle, and then we said, okay, we will have perpendicular bisectors. We'll put the line segments, and it becomes a triangle. And we did this, and we looked at, there's another video for it, what are the perpendicular bisectors of this line and of this line, and a perpendicular bisector of a line where it intersects the other line will be a point. Even if you do the third line, it will pass through the same point, and that was interesting. And this point, if you use as intersect, is the same distance from all the other points. So we could actually going through all 3 points. So this is a circle that is going all around. This is circumcircle all around the triangle. So it's called a circumcircle. And obviously, what is the circumcircle? Is the center of it is called the circumcenter. So this is what we have done before. We have done the circumcenter. So if we say draw, and this is this point. And what was interesting about this point? I had asked for something to be perpendicular. Why did I ask for it to be perpendicular bisector? Because if you have any point in the center, then if I close these two, I can close it with GeoGebra. Why am I doing it like this? If I close it like this, segment from here to here, I know these two are the radius of the circle, so they will be the same. As you can see, L and M, this is L, this is M, they are the same. The radius of a circle. And then if you have the radius of a circle, then we get an isosceles triangle. What does an isosceles triangle mean? That the two angles are the same. This angle always done anti-clockwise, and this angle is the same. So if it's an isosceles triangle, that means if I make a perpendicular bisector, this side is the same as this side is the same as this side, and this is also going to be 90 degree, then all 3 angles are the same. This angle, these 2 angles are the same as these 2 angles, so these 2. And these 2 sides were already the same, so these 2 are exactly the same. This is how we found the point. That's why we drew a perpendicular bisector. In order to find all these, any point on this line would have been the same distance from the other 2. But because we wanted also a point that is the same distance to this, we also took a perpendicular bisector here. That's how you're making sure that you are getting the circumcircle and the circumcenter. These are things we've already done. So let's continue from there. So circumcenter, clear. Now, let's look at what would happen. We were talking about bisector. Bisector means a point that is in the middle of these 2. And there are different ways to do it. And one of the ways we have been looking at is a perpendicular bisector. But perpendicular bisector is perpendicular to this line. It divides it at this point. What if so now let's look at averages. Okay, what is the middle of? Average is just in the middle of. So if I looked at, for example, this line AB, I want to get the middle of it. Then I can do A plus B divided by 2. So it will take the x value of A, the x value of B, add them together, divided by 2. Take the y value of A, y value of B, add them together, divided by 2. What that means is, going from here, going from this value B to this value A, this is in the middle for all the x. Going from this value B to this value A, this is in the middle of the height. So you get the middle. Same way you can get the middle of B plus C, these 2 points. And same way you can get the middle of A plus C. Your A plus C is far away. See, you divide it by 2, it comes here. That's interesting. So this is the middle of all of them. Now, what will be the middle of all 3 of them? So I want the middle of A, B, and C. And what does the middle of all 3 of them mean? Because the 3 of them I have to divide by 3. It means if I what was the mid what does the average even mean? Right? It means that if I have, let's say, 2 people, one person they want to collect. What do they want to collect? Flowers, fruits. Okay, they want to collect fruits. So one person says, okay, you go that side and search, and I'll go this side and search. And I say, no, no, wait, I know. We know there is a bush this side. You will easily find many, many more. He says, no, no, but we haven't explored the other side. So you go and explore, and in the end, we will share. Don't worry. So one person goes one side and they collect berries, and another person goes another side and finds out a new berry, and he's only able to get a few berries. It's going to come. It's going to come. Brings back, and then they share it. And when they bring it together, one person has 7, the other person has only 3. But when they put it together, it becomes 10 and they share equally. That's what this is about. It's about sharing. This is about sharing areas. So we are basically sharing. And so since you want the middle of all 3, what you do is if you take this line from A and get it to the middle of this, and then take this of that. It turns out that when you connect this point and give its weight, this guy already knows its middle. He is giving his weight to this, and this guy is giving his weight to that. They start pulling each other to the exact point, which is the center of this. Which means if you actually cut out this triangle and then you put the divider that you have thin one point, it will balance the entire triangle at one point. You try to balance things, no? This thing can balance a triangle at a point. So if you move this triangle around, for example, points. So say move, you drag this triangle around. This point is actually the middle of wherever this triangle is. It would be interesting to spin it, but we can't spin it in this. And it'll hold it. What we did before, circumcenter, even though it has the same distance from all 3 points, if you attempt to balance it there, it won't balance close to it. It's close to this, but it's not the same. It will not balance. It will fall off. This one will balance. So this is the average of the 3 points. And because it's the average, you use the average of 2 points and connect it to the third point. You took the average of these 2 points and connect it to this point. That's called the centroid. So this next one, centroid, that's this. This is the centroid. If you don't know how to do the average, you can go to the points here and it says midpoint or center. You don't have to write the equation. You can just use midpoint or center. And you can say, okay, point A and point B, I want a midpoint, and will give you one more midpoint. Yeah. That's also fine. You can do that as well. Okay. So in Orthocenter, uh, we are talking about perpendiculars from a point. So that's this one. Here it says perpendicular line. What that means is it's showing there's a line and I can give any point from which I want a perpendicular, which means from here, I can put this at any point. This is always okay. So let's just make sure that we understand perpendiculars. I have a line. It's not a bisector. Bisector means cuts in two. This is not cutting in two of the same size. You can put it anywhere. 90 degrees from the Okay, so that is what perpendicular does. The line will move, but the angle will not change. That's what a perpendicular is. So if I draw the perpendicular line for but passing through A, if I draw the perpendicular to this line passing through C, and if I draw the perpendicular to this line passing through B, then they all also intersect as a single point. And this point is called the orthocenter. Okay. What is so special about an orthocenter? I mean, remember these are altitudes. They're all 90-degree angles. We saw that right now, right? So all these are altitudes. Altitude means height. All these are giving the height of the triangle from one or the other side. So one interesting thing about the orthocenter is that if I take these lengths, if I take, for example, the product of the length AG, this line, and the product to this line length, if I multiply them, so I'll just type it in the bottom, you should be able to see AG times J. Okay, AG times GJ. I get that 6.25. If I take, let's say from point B, BG times G I, is it I? That's also 6.25. And if I take CG times GH, they're all the same, 6.25. So if you move the point around, you move point A around, that's the product of the three, even if it's outside. No, it's inside because it doesn't. Yeah, is going to be the same. So these are the three that we are looking at here: centroid, circumcenter, and orthocenter. And these are the properties.